Hello everyone, this is lecture 2 of Basic Programming and Modeling for Geoscientists. In this lecture, we have already spoken about the architecture of the computer, about the way data is encoded in computers, and the aim of this presentation is to briefly discuss programming languages. So you may remember this weird diagram here. On the left-hand side, there is your hand, which is touching the computer. On the right-hand side, there is some output, a digitized thin section. And in between, you have a structure of the computer that is basically processing information. And of course, if you want to interact in a meaningful way with the computer, you need to be able to pass orders to the computer. So you need a language to give orders to the computer. So languages or programming languages, there exist a lot of them, of different types, different families, and with different aims. So you see a lot of different labels there corresponding to different languages. And for example, one very known programming language is the C language. So the C language is very popular in scientific community. It's very well established. It exists for several decades now. It's very fast and it's open. Another one, which you may recognize, actually some of you already stated that you have experience with it, it is MATLAB. It's also super popular in science. It is very well established. The codes are rather fast. And one of the downsides of MATLAB is that it's not open. It's actually very costly. As a student in Goethe University, you're quite lucky to have licenses provided to you by the university. But if you go out of the university, then you would have to pay yourself a license for MATLAB, which is very costly. So we may not use it during the lecture. Another programming language which is super popular nowadays, it's Python. Python is well established. It's open. It's usually not the fastest codes that you can program with Python, but it's a very enjoyable tool. So what's missing in the list? Of course, I guess you identified that the missing one is Julia. So Julia is very recent, so it's new language. So it's not very well established, but it is spreading very fast in the scientific community. It's open. It's free to use, as you realize. You didn't have to pay anything to install all the software. And the codes which you can program with Julia can be made very fast, almost as fast as C language code. So let's briefly review some of the languages. So the C language is what we called a compiled language. So in scientific programming, C and Fortran would be examples of compiled languages. So in practice, how does it work? There would be more or less 3 steps. So you need a text editor to edit the code. Then you need to compile this code. Then you can run the code. And once you run your code, eventually you can do some post-processing like visualizing the results. So these are different steps. So the codes are very fast, but it's a lot of steps. It doesn't make it very handy for introduction to programming languages, and it's not very accessible. Another type of language is called interpreted language. Examples of interpreted languages are MATLAB or Python. So it's quite different in the way the structure of or the usage of it is simplified, because you basically only have two steps. You need, of course, your text editor in which you edit a code, and then you can simply run the code, and you can include the visualization in this single operation. So this is very handy, and it's fairly accessible, but typically the codes that are produced with interpreted languages are slower than those obtained with compiled languages. And now we have mixed languages like Julia. They benefit from having usage which is simplified. So you also have two steps. You edit the code in your text editor and you run the code. But these types of languages, they are basically hiding a compilation step in a way, which makes them fast. So the codes you produce with a language like Julia can be as fast as a C language code, while the usage of the tool is very handy and remains quite accessible. So it's a good compromise in a way between the compiled language and the interpreted language. So let's have a look, a quick discussion about these different tools. So these are the interpreted and mixed languages which are very popular in scientific programming. And I like to quote this blog from Toby Driscoll. So Toby Driscoll is known because he actually wrote a popular book about the usage of MATLAB for scientific programming. And he recently published a blog post which you can find following this link. So in this blog post, he basically compares MATLAB. He obviously has a very good experience with MATLAB, Python, and Julia. Of course, these are his personal views, but I've been using the three languages too, and I kind of share his opinion. So I'd like to share this blog post with you. So what he says about MATLAB is that it's the BMW 7 of scientific computing world. So it's expensive, and that's before you start talking about accessory, toolbox or packages in a way. You're paying for a rock solid, smooth performance and service. So basically, it's robust, it's quite fast, but it's very expensive. So when you need to add packages like what we do when we are adding, for example, lazy grids and plots in the last examples or tutorials, here you would need to pay additional money even to get these packages. So what I say is about Python is that Python is a Ford pickup. It's ubiquitous and beloved by many. It can do everything you want. It's built to do things that others vehicles can't. Chances are you're going to want to borrow one now and then, but it doesn't offer a great pure driving experience. So it's very handy, but it did not get the best experience out of it, obviously. And Julia is the Tesla. So it's built with an audacious goal of changing the future, and it might. It may also become just a footnote. But in the meantime, you will get where you're going in style and with power to spare. So it's a bit of propaganda, but I found this quote quite funny. So you have the BMW on one side, the Ford pickup, and the Tesla. And the funny thing is that the same author has just written a book. So he obviously went for the Tesla. He updated his book and made the Fundamentals of Numerical Computation Julia edition quite recently. So to finalize about programming languages, what you need to know is that with programming languages, you can do a lot of things. So they are extremely powerful. But what we will do in the lecture, we will not touch all the tools you can use or that are made available to you by programming. We will just use a little bit of them. We will do very specific tasks. So if you ask Google what you can do with coding, you will see that there are a lot of things you can do. And in this lecture, of course, we will not discuss things about cloud engineering and game development, but we will only touch some notions of computer programming, maybe a bit of data processing and research scientist activity. But learning about programming can open you a lot of perspectives. So as I stated before, we only do a little bit of modeling and visualization, and this will be the simple task we do in BP13. So yes, now you know about the structure of the computer. You know that you're sitting on both sides. You want to give information in and receive information out. And in the context of this lecture, the language we use to interact with the computer is going to be Julia. So now I think it's time for some practice.